Alright, this video is about section 4.1, number 118. It's the windshield wiper problem. The windshield wiper problem has a sector, something like this, and then another sector on top of it. The distances associated with this problem are, this whole distance is 25 inches, and this distance that's getting wiped is 14 inches. Right? They also give us an angle of 125 degrees, right down here. And we're told that we're supposed to find the area that's getting wiped, the area that the wiper wipes. So it's this area right here. Right? Look at that art. Fantastic. So how do we find that green area? Well, here's the first hint. Right? Back in algebra, you would have looked at a problem like this. Given a rectangle, and given another rectangle on top of it, if you're given all the sides and all the heights and everything, and your knowledge, right? How would you have found, and again, look at my art. Fantastic. You can just hear the compliments coming through the iPad, right? How would you find this orange area here? Right, what would you do? Okay, I challenge you to pause the video now and see if you can solve the rest of this problem on your own by thinking about this concept and what you would do. Alright, now that you've tried it on your own, we know that what we would do is we would take the area of the big rectangle and subtract off the area of the small rectangle. Right, that would give us the orange area outside of it. Again, you can pause this video and go and apply that to the problem we have, the windshield wiper problem, and see if you can solve it. Alright. So, what do? Well, hopefully you can see now that what you have is two sectors. Right? We have that red sector, and we also have this light green sector. And I know that if I take the red sector and I subtract the light green sector, that'll give me the area of the dark green part up here. Right? That'll give me all that area. The formula we're going to use to find the area of a sector is 1/2 r squared theta. Okay? In order to use this formula, our angle needs to be in radians. So, what we're going to do is we're going to first set up the big sector by saying I'm going to take 1/2 times the radius of the big sector, which is 25, and then we're going to multiply it times the angle, and then we need to change that angle to radians. So you can do the whole calculation just like this. This will give you the area of this red highlighted sector up here. Right? Alright? Next, what we're going to do is subtract off the small sector. Alright, well, the small sector, again, will have the same formula, but this time we don't have the radius yet. We have this value 14, but that's not the radius of the small sector. The radius of the small sector is from here to here. So in order to get that radius of that light green line, I have to take 25 minus 14, and I get 11. Again, that's in inches. So that's the number I'm going to put down here. I'm going to say this is 11. I'm going to square it, times 125 times pi, again divided by 180. You can put this whole thing into your calculator. The only thing you have to be careful about is probably this 1/2 right here. If you put it in your calculator, I'd probably put it in as 0.5, but other than that, you can put this whole thing in your calculator. 0.5 times 25 squared times 125 times pi divided by 180 minus 0.5, 11 squared times 125 times pi divided by 180, and your answer should be 549.8. And we know our units will be squared because this is an area, and it's going to be inches squared because the value they gave us for the radius is in inches, so this would be your number right here. On the test, you're going to have a similar problem to this, and I will tell you what to round it to. For this problem, it's fine just to round it to 1 or whatever you want. Alright, thanks for listening, and I hope this helps. If you have any more questions, please come in before or after school to figure problems out like this or any other problem you have in this class.